What's your view on how to best distribute effort? So there's three, I would say, technical aspects of Autopilot that are really important. So it's the underlying algorithms, like the neural network architecture. There's the data, so that it's trained on, and then there's the hardware development. There may be others, but so look, algorithm, data, hardware. You only have so much money, only have so much time. What do you think is the most important thing to allocate resources to, or do you see it as pretty evenly distributed between those three?
We automatically get vast amounts of data because all of our cars have 8 external facing cameras and radar and usually 12 ultrasonic sensors, GPS obviously, and IMU. And so we basically have a fleet that has, and we've got about 400,000 cars on the road that have that level of data. Actually, I think you keep quite close track of it, actually.
Yes.
Yeah, so we're approaching 500,000 cars on the road that have the full sensor suite.
Yeah.
So this is, I'm not sure how many other cars on the road have this sensor suite, but I'd be surprised if it's more than 5,000, which means that we have 99% of all the data.
So there's this huge inflow of data.
Absolutely, massive inflow of data. And then it's taken us about 3 years, but now we've finally developed our full self-driving computer, which can process an order of magnitude as much as the NVIDIA system that we currently have in the cars. And it's really just to use it, you unplug the NVIDIA computer and plug the Tesla computer in, and that's it. And it's in fact, we're still exploring the boundaries of its capabilities, but we're able to run the cameras at full frame rate, full resolution, not even crop the images, and it's still got headroom even on one of the systems. The full self-driving computer is really 2 computers, 2 systems on a chip that are fully redundant. So you could put a bolt through basically any part of that system, and it still works.
The redundancy, are they perfect copies of each other, or
Yeah.
Also it's purely for redundancy as opposed to an arguing machine kind of architecture where they're both making decisions? This is purely for redundancy.
I think of it more like it's if you have a twin-engine aircraft, commercial aircraft, the system will operate best if both systems are operating, but it's capable of operating safely on one. So, but as it is right now, we can just run. We haven't even hit the edge of performance, so there's no need to actually distribute functionality across both SoCs. We can actually just run a full duplicate on each one.
So you haven't really explored or hit the limit of the system?
Not yet hit the limit, no.